Potential difference. Today I'm going to discuss about the potential difference. Okay, and in the last class we have seen the work done in moving a charge from the point B to the point A. Okay, uh, and we have also seen that the work with the voltage potential difference between the any two points can be given as work done per unit charge. Okay, so this is the equation we got. Now what I'm doing is the potential difference between the A and B is given as, or it is stated as, the work done in moving a test charge q or qt, okay, from the point initial point to the final point. Okay, it can be any point. So here we have taken as the point initial point as a b and the final point as a. Okay, so in this equation I'm substituting the work done equation as minus q integration of b to a e bar dot dl, so which we got earlier, so divided by this q. This is the charge which is moved into the field. Okay, so and now we got again minus the q will be cancelled, minus of integration of b to a, so e bar dot dl. Okay, and I told you earlier that the minus sign is indicated because here the force is applied when the charge is moving from the initial distance to the final distance, which is against the field. Okay, so we have taken an example also. Whenever you are throwing a ball upwards, we are throwing it against the gravitational field, then there should be some work to be done. Okay, so here if we take one small charge which is a positive charge. Okay, this is the positive charge I am taking here. Let us think that it is no enclosed in a sphere. Okay, so let us think that this is enclosed in a sphere. Okay, so here as it is a positive charge, all the forces will be moving away. Now I am bringing in a small test charge qt into this field, against this field. Okay, so that's why the minus sign is indicated here. See here, this red color forces are towards right hand side, whereas this, when I'm moving this towards this, the force is towards the left hand side. Okay, so that's why we are indicating the minus sign, and here it is moved from the point b to the point a. Okay, so this is the initial distance b and a is the final distance, and b is located at a distance of rb, whereas a is located at a distance of ra. Okay, now finally we got the equation as vab is equal to minus of integration of b to a e bar dot dl. And earlier we have also found. Okay, so we know so e bar is equal to q by 4 pi epsilon naught r square. I'm taking as air as a medium, that's why I have taken epsilon not, otherwise I can simply take epsilon. Okay, so ar bar. So this is the equation. We know about e, electric field intensity. Okay, so the difference between force and electric field intensity is the force will have two charges, the force between the two charges we are calculating, whereas electric field intensity is nothing but force per unit charge. Okay, so that's why here only one q will be appearing, the denominator will be same. Now if you see now dl, what is dl? Okay, so now I am not taking it as a Cartesian coordinate system, but I am taking it as a cylindrical, I mean to say spherical coordinate system. Okay, now what could be the dl? Now the dl can be written as, okay, so dl can be written as dr ar. Okay, so it can be written as dr ar plus d theta a theta plus d phi a phi. Okay, similarly in the no you know the Cartesian coordinate systems. Okay, in the same way here also we are taking x y z will be the Cartesian coordinates, but here it is r, theta and phi. Okay, so, but there is one small change which I always telling you, that in the spherical coordinate system here there will be r, and here there will be r sine theta. Okay, whenever you are converting from the rectangular to the spherical coordinate systems, the equation will be something like this. Now what I am doing is this VAB I am taking here. Okay, so which is minus integration of b to a e bar dot dl. Okay, always remember there is a dot product here which we are doing here, so e bar dot dl bar. Okay, so now I am writing the equation of e bar and dl bar. So e bar is nothing but so q by 4 pi epsilon r square into r, which is unit vector, dot so dr. Okay, so ar plus r d theta a theta plus r sin theta d phi a phi. Okay, now as it is a dot product, if you see here as it is a dot product, So AR dot AR, okay, so will become 1, whereas AR dot this A theta, it will become 0, because in the dot product the same unit vectors will become 1 and the different unit vectors will become 0. Okay, so now finally only the first one will be existing. So now the equation will becomes, minus integration of b to a q by 4 pi epsilon naught r square. Okay, and this ar dot dr, it will become 1, so hence here there will be only dr. Okay, so rest of the parameters have been vanished. Okay, now I am doing the integration for this. When I am doing the integration here, first of all take out all the other parameters here. So this is b, so this is a. Okay, so this is b, this is a, and now so just a minute, I will be erasing this one. Okay, so I will be taking to outside all this. So this will be minus, so q by 4 pi epsilon I am taking, so q by 4 pi epsilon I am taking, so integration of b a. Okay, so 1 by r square. Okay, so 1 by r square, so dr. Now you need to take the integration of this 1 by r square. Now this integration of 1 by r square will become, so this will become minus q by 4 pi epsilon naught. Okay, and finally in this integration, before this you can able to take as integration of b to a. Okay, so r power minus 2, I am taking it up in the numerator, it will become like this. So finally after doing this integration of r to the power of minus 2, I am directly writing the final equation here. So VAB, so this will become, so this will become, so Q, okay, so minus will be there obviously, 4 pi epsilon naught, okay, 1 by RA plus 1 by RB. After substituting the upper limits and the lower limits, finally you will be getting this. Okay, now I am rewriting this equation as this minus is there here, so here also there is a minus. I will be just taking out finally, so 4 pi epsilon. When I am taking this minus n here inside, so then this equation will become 1 by RA minus 1 by RB. It will become like this. This is the final equation of the potential difference between the points A and B, potential difference between the points A and B. Okay, so now what I am doing is, so this is the potential difference between A and B. So initially we got minus integration of B to A E bar dot dl bar. Okay, so now, so after taking no some sphere, okay, so as a positive charge, so then finally you will be getting the equation when you are moving in between the 2 points. Then the equation will be something like q by 4 pi epsilon naught 1 by Ra minus 1 by Rb. So this is the equation. So now let us have a small question. Okay, as let us have a small activity. Okay, so here I got this equation as VAB is equal to q by 4 pi epsilon, okay, 1 by Ra minus 1 by Rb. Now tell me, suppose let initial point is at infinity. Okay, so is at infinity, the initial point is at infinity. Okay, and the final point is at, and final point is at A. Okay, so then what is the VAB, what is the potential difference between AB? So this is the question. Okay, so take time of 5 minutes. I think this is 3 minutes is enough, I hope so, because this is a very simple one. Okay, this is small activity, so that based upon this, so I'll be telling you how the potential difference will changes, and what it is called when the initial distance is, when the charge is moved from the infinity. Okay, so take a time of 2 minutes, 2 to 3 minutes, and then you can able to write your answers. So this is a small activity where you need to substitute one value. So once again, hint I am giving you something like the initial point is at infinity. Okay, so as we told that the initial point is B and the final point is at A earlier. Okay, so just to think, so what you can able to put at the initial point. Okay, so or the initial distance, as in the question it is mentioned that the initial point is at infinity. So it hardly take 2 to 3 minutes to think just and write down the equation. Okay, hope you have written, but those who face difficulty in identifying what you have written and all, so that I will be explaining here. So if you see VAB, again I am writing the equation. Okay, my Q by 4 pi epsilon 1 by RA minus 1 by RB. This is the equation. Okay, so potential difference between the A and B. Now when I am taking this okay, so if I am taking RB, okay, so the B point B is at infinity, so the distance will also be infinity. Okay, so it is located at an infinity distance, so RB will be infinite. Okay, whereas RA I have not disturbed it, so RA will be RA because the point A I have not disturbed, the final distance I have not disturbed, it is located at A, whereas the initial distance is at infinity. Now this equation will becomes VAB is equal to Q by 4 pi epsilon naught 1 by RA minus 1 by infinite. So what you will be getting now? So Q by 4 pi epsilon naught 1 by RA minus 0. Okay, so this equation will become, now it will be VA. I will tell you why I am writing this as VA. So it will become 4 pi epsilon RA. Now this is called as an absolute potential. Okay, so because if you are taking any point as a reference, here I am taking it as an infinity, or let it be some reference, because there is no fixed value for that. Okay, so whenever I am taking this as a reference point, so then we can say it as a absolute potential. So most of the, for practical circuits, generally the reference point, so generally you can able to see that there may be a zero reference point which is selected as a ground, right? So all the potential of that circuit are measured with respect to that ground, which is treated to be the zero potential difference. So that is one of the example. Okay, and also there will be examples like a shielded cable is one of the example. Okay, so instead of a potential difference, it is more convenient to express in the absolute potentials of various points in the field. So if you are taking any field, you can able to take various points. So such absolute potentials, as you are seeing here, VA is the absolute potential. These are measured with respect to the specific reference positions. Okay, and these such a reference positions is assumed to be a zero potential. Okay, and some more examples like similarly in cathode ray tube, the metallic shield around the tubes are taken as the zero potential differences. Okay, so and with respect to that references, potentials of various points are measured. Okay, so this is the absolute potential at the point A. In the same way, if you are taking any other point, so absolute potential at the point X can be written as, so Q by 4 pi epsilon naught R X. So this is also an absolute potential. This is also one absolute potential. So this is about the potential difference and the absolute potential. Now if you want to take, so we can able to take VA as an absolute potential and VB as a absolute potential if you are taking any other reference points. Okay, so generally if you are taking VAB generally it is a combination of the two absolute potentials. It can be given as the voltage at the point A minus the voltage at the point B. Generally, what is VAB? VAB is the potential difference between the points A and B, and this VAB can be given as VA minus VB, which means that the absolute potential at the point A and the absolute potential at the point B. So finally, you will be getting the potential difference between the point AB. Okay, suppose this is a point A. Generally, you can able to see. So this is VAB between the 2 points. Okay, so this is the point A and this is point B. So this will have one voltage at this point, and this B will also have a voltage at this point. Okay, so generally we can say able to say in the circuits you can see as a node voltages also. Okay, so this voltage again minus this voltage. Okay, so difference between these two terminals or the points, it is called as the voltage difference VAB. That's what we have seen now. Right, so thank you. In the next class what we can see is we will be seeing some equipotential surfaces. We'll be seeing. Okay, so next we'll be seeing, like if possible we'll be solving few of the problems on this, and we'll be seeing the potential gradient in the next class, right? So thank you.